Assalamu alaikum students. Today we will learn the polar form of complex numbers. You know that polar form, complex number are of the form x plus iota y, and this is actually called the polar form of these complex numbers. We represent them that complex number into a function of r and theta, and this is how it is done. Suppose we have a complex number x plus iota y, and it is drawn on the graph. You see that this is the abscissa of that complex number, and this is the ordinate of that complex number, and it makes an angle theta with the horizontal, and this is actually the resultant of the complex number. So if you see that we have a trigonometric ratio cos theta equals to x over r, and sin theta equals to y over r. Because cos theta is equals to base over hypotenuse, and if we use this as a right angle triangle, this is the right angle. So this will be the perpendicular, this will be the base, and this will be the hypotenuse. So cos theta will be equals to base over hypotenuse. So we will get the cos theta is equals to x over r, and sin theta will be equals to perpendicular over hypotenuse, and that will be equals to y over r. So we can find out the value of x in terms of r and theta from this equation, and it is here. And similarly we can get the value of y from this equation in terms of r and theta, and this is here. And when we put these values x and y in this complex number, it will be r cos theta plus iota sin theta, r sin theta. So if we take r common outside, that would be cos theta plus iota sin theta. So this is the form which I have already written over here. So this is the basic idea of what is the polar form and how we can convert it. So we will just solve a few examples. Suppose I have a complex number 1 plus iota, and I want to convert into polar form, and it will be written in r cos theta plus iota sin theta. So the basic thing is here we will search we will find out what is r and what is theta. So these are basically two unknowns to find out the polar form of complex number. R is very simple. If we take this x and here we take y, x is 1 and y is 1. So if we draw again, this is r and this is x and this is y. So if you apply the Pythagorean theorem, we will have r squared equals to x squared plus y squared. So here r will be root x squared plus y squared. If you put the value of x and y in it, we will get 1 squared plus 1 squared, and it will be square root 2. So this is r. Now the only unknown remain is theta, and we will calculate the theta and just put the values in this equation, and we will get the polar form of that. Theta is a bit tricky part, and you must know some basic concepts so that it would be easy to find out the value of theta. Let me write those formulas over here. Theta can change in different quadrants. Suppose if complex number lies in first quadrant, then theta will be different, and if it lies in second quadrant, then the theta will be different, because it is like a cycle, and it has two values in one theta, because cos theta can assume two values. And if you have here we have all positive, here just sine positive, here tangent positive, and here cos positive. So we may have two different values in two different quadrants for the same theta. Suppose we have if like we have cos 45, it would be something cos 45 is, I think, 1 over under root 2, and here there will be another angle where it will also be 1 over under root 2. So tackle that problem, we will just use some formulas. First I'll just write them over here. if the complex number lies in first quadrant, then our theta will be just tangent inverse of y over x, and in second quadrant theta will be pi plus, pi means 180. If you are not familiar with pi, then you can write 180 degree, okay, 180 plus tangent inverse of y over x. And in third quadrant it is again same, 180 plus tangent inverse of y over x. And in third quadrant it is 360 minus, or tangent inverse of, I should say 360 plus y over x. So here I'll just check that in later. So first, this is our first quadrant. So here we have theta lies in first quadrant, so we will just apply this formula, and theta will be tangent inverse of y over x, and y is 1 and x is 1. So this is actually, theta is tangent inverse of 1, and this is equals to 45 degree. So if we use the value of r and theta in this, we will get the polar form of this complex number, and it will be 1 plus iota equals to r is under root 2 cos 45 plus iota sine 45. So this is actually the polar form of 1 plus iota. So let me solve a few other examples in different other quadrants. Suppose I have 1 minus iota. So all you know that here x is positive, y is positive, here x is negative, y is positive, here x is negative, y is negative, and here x is positive and y is negative. So here x is 1 and y is minus 1. So this is positive negative case, so it lies in fourth quadrant. So just I think I should do that. I should solve this 1 minus 1 plus iota, so that it may lie in second quadrant. We will just go in order so that there is no misunderstanding. So this is minus 1 and this is plus 1. So if you see that r is again x squared minus 1 squared plus 1 squared, so it will be again under root 2. And now if we see theta is actually it lies in second quadrant, so theta will be 180 plus tangent inverse of y by x. And if you put the value of y is 1 and x is minus 1, and if you use a calculator to find the value of tangent inverse of minus 1, that would be minus 45. So our answer will be 180 minus 45. So it will be 5 and 135. So theta would be 135. So if we see that this is 90 and theta will be something like here. So if we just put the value over here in form of r cos theta, r is again under root 2 and cos theta is now cos 135 plus iota sine 135. So this is the required polar form of minus 1 plus iota. Okay, I think that for the required length on YouTube, we should stop this lecture over here, and we will do the next two parts in next lecture.